Hey everybody, welcome. Today we are presenting Jeff Morris, VP of Product and Solutions Engineering, and Matthew Groves, DevRel Engineer. And we're going to talk today about the differences between Couchbase and MongoDB. Before we get started, I do want to remind you about the docs. We have a great white paper in there for you, a copy of today's presentation, an invitation to next month's webcast, and we are conducting a user evidence survey. We'd love to get some feedback from you. That's the second selection there in the docs. Would love to hear your feedback about how you use products, and that will help us to build much better in the future. And with that, I will go ahead and kick it off to Jeff and Matthew. Thanks, Jeff and Matthew, for being here.
Oh, thanks, Suzanne. Hi, everybody. It's great to talk to you all again. Hi, Matt. How are you? So this is going to be a fun conversation. What we'll end up going through is sort of what the differences are between Couchbase, right, our NoSQL database, and MongoDB. And it's not clicking. There we go. So before we hit on that, let's give everyone a reminder. You do use Couchbase pretty much every single day. You just don't know it. When you're logging into LinkedIn, for example, right, all of your feed is cached inside of Couchbase. Or when you go into a Louis Vuitton, because I know everybody's shopping there still. Every time they show you their tablet of what their worldwide inventory happens to be, that is a Couchbase application. But if you're sending money via Western Union, they're a evolving online bank. Whether when you're ordering Domino's, that activity is powered through Couchbase. When you're playing EA Sports, right? When you're going on a cruise, most of the cruise lines use us. So you run into Couchbase pretty much everywhere. Now, Matt, as we sort of lay the groundwork here, the kinds of things that we're doing is we're typically building we're an application-centric database, as is MongoDB. But what we're doing is we're serving large communities of users, typically with personalized account profiles. That's one of the things that both ourselves and MongoDB do really well. This number of customers, these 9 customers here, they represent somewhere in the neighborhood of 7.5 billion account profiles being managed in Couchbase. That's just these 7. And I'm not even mentioning some of the other major customers that we have in our install base. So the commonality here is that these account profiles, they need to be dynamic. They need to be scalable and really easily manipulable, so that as our customers are serving their user communities, they can actually create better and better experiences for all of them. And I think that whole exercise that we'll end up continuing to discuss as we go through here, right? It's 3 billion accounts handled by FICO, right? As protecting 9,000 banks from fraud. One of your favorite vacations we were just talking about is being at sea. Carnival's using us there. They're automated city at sea. There's like 15,000 sensors around the ship that is keeping track of what everybody's doing, where they are, where's your family, those kind of things. Another great application and example. I mentioned LinkedIn already. You'll find us in lots of retailers as well. Again, delivering those matching account profiles to big product catalogs is one of the areas where we find ourselves a lot. So some of the reasons here why are people picking us, right? And maybe Matt, you could talk a little bit about, I've kind of addressed the flexibility angle of using JSON, but there's some other really clever innovations built into Couchbase that not only make the flexibility of JSON as one of the original drivers as to why there is a JSON database or a bunch of them and why there's not, performance at scale is really another big one. And so we'll get into that and as we go along. And then some of the other interesting differentiators. So this is the one that Groves, you lean on me all the time about, is SQL++ being that's our query language, but being basically a sibling to SQL, right? Share the same syntax, but use it for JSON. And then recognizing that JSON as AI applications start to take hold, that JSON, because it's so dynamic, because it can accept data from in a variety of formats, it's going to be the format for the data format for AI, because structured schemas are really difficult to manage there. When you can't anticipate what a large language model is going to say to you, right? You want to have that flexibility to capture whatever kind of answer to your prompt an LLM gives you. JSON's great for that. But then, of course, these systems, they all need to be highly available, and resilient. They and they need to be affordable, right? So driving down cost of ownership, those are all areas where we'll continue to explore in this in our conversation here. So the key things that we're trying to address, or that you'll see in across the board in not only ourselves but also in other different NoSQL databases, is coming up with designs that support this performance requirement. We do so with built-in caching, baked into Couchbase. Having that data model flexibility with JSON, that's a key element. But supporting many of the traditional things that like relational databases have done for 50 years, being able to support transactionality, being able to support high volumes of both connections and users, being able to support structure when you need it, but not necessarily demand structure. And then being able to support different data access methods or data access types, like search, as well as direct query, or like being able to programmatically capture events that are happening inside the database. All of those are key elements here, and it sort of created the whole NoSQL space, right, with all kinds of different types of databases based on how they're accessing data, or in some cases how they're storing the data. You've got things like vector databases now. You've got graph databases. You've got search databases. You've got relational databases. You've got JSON databases, key value ones, etc. Right, but the fun part about ourselves is we're sort of the amalgam of all of those. And kind of the intersection of lots of different functionality from different flavors of databases. And one of those final elements to support high availability and to support lots of users roaming the planet is having active clusters, or also having mobility built into your system. Those are areas where these kind of capabilities we'll find lots of solutions for, but Couchbase is, again, one of those sort of all-in-one kind of cases. So reasons why people end up picking us, is that memory first speed, right? That's kind of the hallmark of Couchbase is it's a really fast database. And I'm not saying we're the absolute fastest in every case, but we're pretty hard to beat. And so that memory-based architecture, Groves, you're gonna have to walk me through that in a minute. But also married that up with the active clustering and the cleverness that we built into our cluster map, which gives us a lot of advantages over other systems. That flexibility of JSON, and we've already started to touch on, but as we look at the way the world is evolving, the way technology is evolving now, just being able to support new things like new data types and new things like vectors, and having robust vector indexing, so that you can indeed use your proprietary data with a large language model without necessarily sharing that data, right? You kind of make pointers to it and give your LLM clues as to where everything is, without necessarily training data on data that you consider to be extra special to yourself. Mobility will hit on a little bit more, because we all carry phones, and we see that as a continuing advantage for ourselves, but also a growing need in as we start to build AI-based applications, right? What's the interface that we're all using to talk to ChatGPT, for example? It's, the microphone on your phone. So having an ability there to support local on-device applications with local on-device kinds of synchronizing databases, again, great advantage for ourselves, and we'll dive into that too. So where do let's talk about kind of the use cases that we end up continuing to support. That caching use case we'll pick on a lot. User experiences and personalization with account profiles and having dynamic account profiles we'll keep hitting. Agentic applications and supporting retrieval augmented generation exercises. That's kind of the new space that we're all beginning to play in. I've got opinions on how that is progressing that perhaps we'll hit on in a minute. I think that there's still a lot of reticence in the market about trusting large language models before we dive really headfirst into building lots of different agents. We've got to make sure that we trust the outcomes as to what the models are going to say, or what we're going to instruct your agentic systems to go and do. But product catalogs, customer 360, those are really common use cases. These mobile applications, field service applications, those are really things that we see ourselves in a lot. And of course, operational analytics. And all of that kind of buckets itself into that master level design of Couchbase's platform. Right, we've got the traditional Couchbase stuff is really that transactional services box. That's what Couchbase Server has always been since about 2011 is when we came out at first. So we're pushing 14, 15 years old now. But then we've got our mobile services, as I've started to mention. We've got analytic capabilities. We just had Enterprise Analytics was released for self-managed deployments back this past month in August. So that was a big breakthrough. We took our Capella columnar capabilities, Capella's analytic services, and created a self-managed environment for that. So anyone can download that. And if you're still one of those customers who are operating your own data centers and your own cloud environments, Enterprise Analytics is available for you there. It's got a great feature called that allows us to take a metric and write it back to the operational side of Couchbase. That's pretty cool, and we've got a bunch of customers using it for that. And then finally, the AI services. We'll hit this again. We've been talking about it since November of last year. These are really what we're very, very excited to have brought these to market and continue to evolve those throughout the course of this fall and this winter. But what we end up talking about with the platform is we're really one of the few vendors. Mongo is pretty close to this too. One of the few vendors that has this variety of capabilities across, within a single platform, and that it can run in the cloud. It can run on, as self-managed kinds of deployments, and has commonality across the board. Commonality being JSON, commonality being SQL++, the query language, commonality being all of the different interfaces that we offer to applications themselves to access all of these services. Matt, any thoughts on the overall platform here that we're describing before we jump into what's the differences between ourselves and the other guys? You're on mute, bud.
Sorry, I just want to reiterate there that all those platforms are available for enterprise. If you want to manage them yourself, Capella, you can do a lot of that. We do a lot of that for you on all those cloud platforms, and there's a free tier right now. So if you want to go ahead and just try that out, there's no credit card needed. Just go ahead and sign up, and you can start using Capella right now.
Yeah, that was a big deal when we came out with that late last year, the full free tier. Kind of getting ourselves back to full state of the market sort of thing with our cloud capabilities. So let's talk a little bit more about the kind of things that we end up the original Couchbase, the transactional services, and Couchbase Enterprise do. And we've started that discussion from the data access services. Each of those are basically services in their own right that operate within the database or within a database cluster. So you have access to JSON documents. That's your primary data format that you're working with, but it's stored as a key value data, deep in underneath the system in that database we call Magma. That's our own key value environment, very high performance, very modern in terms of design. It's got the log structured merge style of design that helps clean itself up, helps compact itself while it's running. Pretty clever kind of capability there. But you've got key value access. You can use our SQL query engine for writing your queries. You can use our full text search engine for accessing your documents, using a search style. We've got an eventing service, which does things like change data capture and trigger other programmatic activities while the data is being processed. We support time series data with some clever extensions to JSON. We have our own copilot called Capella IQ or a Couchbase IQ that does natural language query. We built in common table expressions to do graph traversals inside the query engine. So that's pretty clever. And then all of these other things that are at the bottom, caching, active clustering. The cluster map is what drives the active clustering mechanism. We'll touch on that. That's some of the best idea Couchbase ever had was the cluster map, I think. We've got geographic replication and synchronization capabilities, cross data center replication capabilities. We support ACID transactions. We've got 5 different patents in supporting transactions for JSON. Magma I've touched on, and then coming up, billion scale vector search and billion scale vector indexes built into Couchbase Server. That's what Suzanne was pointing to. Our next major event that we're going to be talking about come next month is Couchbase 8 is coming out, and its release defining feature is this billion scale vector index capability. So we'll touch on that a little bit here, but I don't want to give away the impact of what that's going to do when we talk about it next month. All right, so Matt, you work a lot with these guys. We have a vendor that that we work with called Benchit. They're based in Germany, and they do a lot of database analysis. So why don't you walk me through a little bit of the things that they are talking about here?
Yeah, sure. So these guys just like live and breathe benchmarks. That's their entire business. That's their entire lives. And what they've put together that's I think is very interesting and kind of different than other benchmark providers is this thing called the DBAS Navigator. So this is an attempt to benchmark cloud-based databases, database as a service, on 5 different dimensions. So normally we think of benchmarks as just performance, right? And that's one of the 5 aspects here is performance. But they've also measured other things about it, like how easy is it to manage, what's the pricing like, what's the support level, what are the different APIs that are supported, and all those different aspects. You can drill down to each one of these and see all the different criteria that make it up, and they compile this into a big scorecard. And so Couchbase, obviously, as Jeff's been saying, we do very, very well on performance. Like that's not a problem for us at all. But as you can see, the other categories were also very, very good. And so overall, right now, at least when this picture was taken, we are the leading DBAS navigator on score on their scorecard. So I encourage you to go check out their site, benchant.com. You can see this navigator. You can drill down and see all the specific things that make up the score. And it's just a really interesting way to go about a comparison that's more than just a pure performance race.
Yeah, I think that's one of my favorite things about them too. Is exactly that. Is they give more of a comprehensive view over everything. So let's talk a little bit about where does that performance really come from inside of Couchbase. The first thing we typically talk about is this our memory first design, and how it supports our asynchronous architecture. That means it does a lot of work all simultaneously, all at the same time. So. But what it's really explained to me, because what this DCP, the data control protocol, is really doing here.
It's data change protocol. So DCP is kind of a Couchbase. I like to think of it as a bus, but it's more of a protocol for just publishing events throughout the entire cluster. So if some data changes on, let's say, node 2, other nodes are listening to DCP and they can respond. They say, "Oh, we'll make a backup copy of that on node 1 and node 3. We'll update the index service on node 4, etc." So it's a way to kind of let the whole cluster know and let it keep up and understand what data is being changed. It's a lot more complex than that. It's a way to kind of like an accounting ledger of data, if you will, as changes are made, that just keeps them all updated. And it's all done in memory. All right. So that's the key thing that helps with performance here, is that it doesn't have to wait. There's no blocking functions to wait for disk reads or writes. There are disk reads and writes, but those aren't waited on. So it all happens memory first, and that's one of the things that helps us to be much more performance.
Yeah. And then another really clever one. So you'll notice that as we've laid these first couple of pictures out, we're showing the different engines or the different services inside of Couchbase database: the query engine, the indexing engine, the data service, the full text search service, the eventing service, analytics service, etc. Each one of those are their own engine. So what's clever about Couchbase is that you can decide how much resource on which to apply those engines themselves. And so you don't have to run the whole thing on one node or across all the nodes. You can pick and choose what services go where. And the only thing that's common across the board is the cluster manager. Any other comments on this multidimensional scaling kind of feature?
Yeah, I mean, you think of it almost like a microservice architecture where all these things are communicating via DCP with each other, but you don't have to use all of them, right? And when you're developing, you may want to stack them all up on one node, but in production, that's probably not the best way to go. So you have options on how to deploy them.
Yeah, and all the nodes, they don't have to be the same size either, right? So you can optimize them for their memory footprint. You can optimize them for their CPU counts and whatnot, just based on both the needs of the application as well as what the services themselves are doing. And then so we've got a question about what happens when we lose a node here. We'll get into that and how Couchbase supports failover, and maintains a highly available kind of environment. So when we measure ourselves against many of the competitors, we've been doing ourselves benchmarks for years and years and years. Hiring third parties to go and exercise us along with other products. So while this may seem aging, the benchmarks themselves were released in April of 2023, so they're about 2 years old now. But materially, none of the products have changed all that much in terms of how and what they're capable of doing. But you want to walk us through the charts here, Matt?
Sure. And just another point to that is I've been at Couchbase for 9, almost 10 years now, and I've seen these benchmarks, every year, every other year, and the trend has been basically the same. It's just that the absolute numbers get bigger, but the comparisons are still the same. But anyway, this is a snapshot from one of our benchmark reports from YCSB, which is a standard cloud benchmark for databases. And this one in particular is workload A. And I bring that up because there was a question in the chat about, what kind of reads and writes can Couchbase support. So this is a 50-50 read-write workflow. So 50% reads, 50% writes. And so on the left there, you've got operations per second. So higher is better, right? So Couchbase is in red, just absolutely killing it there compared to Mongo, Dynamo, and Redis. And then on the right side, it's cost per billion operations. So it's not just about how fast we can go, but how fast can we go and fit in your budget or reduce your TCO, right? So in that case, on the right side, lower is better, right? So you can barely see Couchbase on that graph. We're doing really well at providing you fast operations and a lot of them for your dollar. So that is that one particular workload. There's others in that report as well. I encourage you to check out the whole thing, but that's what those graphs are showing there.
And then let's talk again about our friends at Benchant with what they've been doing.
Right. So another thing Benchant does, this is great, is they have something called I think they call it database ranking. This is their original kind of product, their original innovation, is they have an automated benchmark framework that they can just run benchmarks whenever they want to at their whim. And so they keep a detailed public rank of all the databases and their throughput, their latency for reads and writes. and they rank those all. And Couchbase is number one, at least the last time we looked, and it's 6 of the top 10 right in there. So you can look at Benchant's third-party data and see where they come up with. There's lots of different cluster sizes and configurations and cloud providers, but Couchbase is very much on the top of this list. On the flip side of that, Mongo, who we're going to be talking about today, their highest rank is number 41. Right, so that's kind of the comparison there in terms of speed, performance, throughput, and these are all happen to be the self-managed. So these are the Couchbase server that you deploy yourself, right? So that's what they're measuring with this particular rank.
And then even more recently, looking at when version 8 came out of Mongo, that's their newest, fastest release. They touted as being percentage points faster than before. Awesome for them, but still, they're in comparison to what Couchbase is able to do, still doesn't hold a candle to what we're doing on same hardware, same environment, same kind of work.
So this is an internal benchmark that we've run ourselves, not a third party. But I will encourage you, I think there's a link actually in the docs, is to check out, we got a whole separate webcast on the details of how we do this and how you can do this yourself if you want to verify these numbers. This particular graph here also shows workloads A through F. So all 6 of the YCSB workloads, you can see how much better Couchbase is doing in this case compared to Mongo 8.
All right, so I think we've laid the groundwork for, if performance is the sole reason why you're choosing your database, and for the last 50 years, that's the number one reason why people are, comparing databases themselves, is which one can handle the most data and do it the most quickly as possible. And so, like I said, I don't think we don't win every single race, but we do pretty well in every single race, and we'll put it to the test against pretty much anyone. So now let's talk a little bit about JSON, Matt. Is JSON as the kind of the data format? The great thing about it is that you can change a single document from within the application at any time, and you don't have to. You can add fields to it. You can add full sub documents to it whenever you want, and not affect all the other clients of the application or all the other instances of any other document. That flexibility is pretty remarkable and quite a step change from the relational world as to why folks are still using relational databases when JSON gives you a lot more versatility and flexibility here.
Yeah, I agree. We're getting some questions in the chat now about that. We can touch on those later for sure. But yeah, the difference here is, with relational, I always think of the paper shredder analogy is when you're storing something in relational, you put a piece of paper through the shredder. If you want to get that paper back out and read it, you got to put all those parts back together. Versus Couchbase, it's a single document. You don't put it through a shredder. You just put it right into the file and store it that way. Now, there's obviously trade-offs and things you have to think about and modeling differences. So it's not exactly always going to be better, always going to be easier. But I think there's a lot of benefit to gain, especially from the apps you talked about at the beginning, Jeff, all those flexible apps at huge scale from using JSON as a data format. And certainly as we move into more AI agentic applications, those benefits just keep compounding.
Yeah, you remember how long it used to take to roll out a new version of the database, a new version of schema, right? You'd be like, I got a plan for that. It's going to take us 6 months to do, and just brutal IT DevOps kind of exercises to get it, make a database, a relational database evolve. So JSON helps, correct for that. But then let's talk a little bit about when we look at ourselves versus Mongo, right? How do you organize the data itself for some kind of logical design? Because, while we talk about JSON being really flexible, you also want it to sometimes have real structure so that you can organize your thoughts and organize the data accordingly. What's the difference between these two here?
Right. So I always think about, we talked about SQL++ being a familiar and that would be one of the benefits of having that available with JSON data. But this is even another step to making it more familiar. Is Couchbase, and it's kind of hard to see in the slide here, but on the right side there, you can kind of map relational concepts to Couchbase concepts. It's not the same exact thing, but they're very similar levels of mapping. So for instance, you have a table in a relational database, and you have a collection in a Couchbase database. You have a schema in a relational database, and you have a scope in Couchbase, and so on. Now, so Mongo is kind of similar in that they have a concept of databases, and the databases just have collections, and that's kind of all the organization you get. And so with Couchbase, you get some additional levels of organization that kind of help you map to those familiar relational concepts a little more straightforward.
Yeah, and we always like the concepts that we're all kind of born with, or we learned years or decades ago. If you're me, that mapping of you've got a server or a cluster, you've got a database or a bucket, you've got schema. Ours is called a scope. You've got tables; those are collections in the NoSQL world, and then rows are every document. That makes perfect sense to me. And then so when you look at it in terms of what a query can do, carry that same familiarity over. Like I learned SQL in the 90s, and it's very super easy to read. It's a declarative language, right? That's which is just so much more convenient for people. It's just tell the database what you want, what you're looking for. It'll figure out how to do it. Versus imperative languages that are much more verbose and much more tedious to write and maintain and ultimately to debug sometimes. But any other comments on SQL++ here, Matt?
Yeah, so when my first job out of college, I worked for a business office, and I was the only developer in the business office, but pretty much everybody knew how to write SQL there, at least some basic SQL. So I'm not saying it's a universal language, but it's a language that's very approachable, very readable, easy to understand and look at. And I just think it's the default language for working with data, or at least it should be anyway.
Yeah, and then we compare it to what you end up getting with when you're querying when you're using Couchbase versus using Mongo. The same fetch here is you can see the SQL 92 from a relational structure on the left, SQL++ in the middle there, and then all that other stuff there, lots of curly brackets and whatnot for writing in Mongo. Thoughts on doing that, Matt, as the the developer in the room here?
Yeah, so I mean, my background is relational SQL, and this is one of the reasons that attracted me to Couchbase in the first place was I could take that same great language and apply it to NoSQL data. And with Mongo, you've got this whole different proprietary language, and not only is it difficult to write, but I think it's also difficult to read as well. And as developers, I think 90% of the time we're reading code, not writing it. So I think that's a big benefit there.
So the old things that what a relational database does really well, of course, is ACID transactions, right? It supports transactionality, and so it took a while for all of these NoSQL vendors to come up with, all right, what's your design for supporting durable, isolated transactions, and so we've done that, and as I mentioned earlier, we've actually gained multiple patents based on this for doing transactions with JSON documents that are all ultimately pretty clever. But the best part about this is you can do the same things that you would be doing with a Postgres or an Oracle kind of thing, moving money around. We've got tons of customers moving money around within Couchbase, and depending on our transactionality to do so. Okay, we've got a couple of questions, Matt, on how are we doing our clustering kinds of capabilities, and what is it in there that we had a question earlier about how does our failover behave, and how does it how do we know if we lose a node? The key thing I want to mention here, though, is the cleverness in My favorite thing at Couchbase was that cluster map. And the cluster map, when you build a database or you define a bucket, it automatically creates a map of it's 1,000 rows, or coming up you can pick between the big map or the little map. But what it basically creates a table of virtual database structures that you're going to be putting the data into, and then when we move that around, when we're partitioning or rebalancing a series of partitions, We're just updating that particular location map and feeding that back to the application. So the application knows where its data is all the time, and and the magic of Couchbase is that the application always knows, so you never have to ask.
Yeah, so one of the things, I wouldn't normally go into this much detail, but there were some questions in the chat that I think we should address. So the diagram here shows 2 nodes of Couchbase and then 1 app server, and then the client, like the cluster map you were talking about. So that cluster map is you mentioned 1,000. It's 1,024 different locations basically that data can be stored, and those are called V buckets. Basically, they're a form of sharding. And so based on the document key, so one of the questions in the chat was, how do you hash this up? It's a CRC32 hash. Based on that key, it knows which V bucket that data lives in. And so it knows which server that V bucket lives in as well. So we can go from the application directly to the server where the active data is. We don't have to go make extra network hops to get there. So you can go directly to that data, and chances are it's going to be in memory as well. So we're talking very, very fast, read and write access to data going directly to the server from your app server. And then this case also shows what happens in a failover. One of those nodes goes away. I don't know what happened to it. It crashed or a hard drive broke or whatever. That means the replica data in the other nodes is then promoted, and that's during the process of failover. It's promoted to be active. So there's basically like a backup copy on other nodes. So there can be. You can specify how many copies you want to. They'll be promoted to active. And then what that basically means is you're not going to have any downtime if a node goes down. And that gives you, with failover, you can then go ahead and add some more nodes back in, or with Capella, we kind of handle that for you, sort of thing. But that's all handled by Couchbase. You don't have to configure as a developer. You don't have to set up the sharding yourself. It's just all automatic. It's built right in. It's a drop down, basically. How many replicas do I want? It's 1 through 3. And that's the extent of it. After that, Couchbase will handle it for you.
Yeah, automatically sharding it. You don't have to remember where you're going to put it, what key you used, all those complications that not only Mongo but other systems do. They're just again, the thing that I fell in love with at Couchbase was that auto partitioning functionality, because I was working for a different NoSQL database that was having a really tough time figuring out how to break its data apart and support support a sharded database. Anyway, so this also shows where the active data originates. Then it gets written out to its replicas. Every node has participates both in holding active data as well as holding replica data. Any other thoughts on this before we do a kind of a compare and contrast to what Mongo's design is?
I mean, this is basically what I was saying in the last slides. Yeah. I kind of jumped ahead. Sorry.
It's okay. So now let's talk. So that was kind of the basic design. It's not a leader follower kind of architecture. It's asynchronous active kind of architecture. But the cool thing that we do here also is we manage the resources of the machine really effectively. So there's this notion in Mongo that when you're when you install it, you're installing like big Mongo on every node. And it's a leader follower kind of design. So you have the one node takes all the writes, and then it spreads them out for read access to its replicas. And when you set up for that, you have to dedicate about half the RAM for each node to running the operating system and the database itself. And then it dedicates another half of it for their underlying data store, Wired Tiger. That's kind of the equivalent of Magma, in our speak. Nice database underneath that, but it's not nearly as efficient because they're a leader follower design, not as efficient as what Couchbase offers. Because with us, right, you dedicate we say 10% or so to the operating system. And then the remaining half to the active virtual buckets that are being hosted by a node, and then the other half for the replica virtual buckets. But what you end up getting here is the accumulated cache for all of these, in the active state for all the cluster. So I get, what, 45% of each node per, as my active cache. So my cache is what, almost 4 times or 3.5 times bigger than what Atlas would do for caching Wired Tiger. Did I get that right, Matt?
Yeah, this is kind of a complex slide. So, if you're out there looking at this and having a hard time with it, that's okay. It took me a while too. But what this is trying to show is that for Couchbase, we've got 3 nodes, and for Mongo, we've got the same 3 nodes in terms of hardware, right? But the way the architecture works is that if you want to have high availability, if you want to have replicas to prevent or to guard against those nodes going down, the way Mongo works is you have 2 secondary nodes that these do not handle writes. They're read only, essentially. They're really only backup only. And the reads and writes go through the first node, node 1. Now, Couchbase is different because every one of those nodes handles reads and writes. And now we just set up a hypothetical here, 45 for each of those. You can adjust that with Couchbase. You can absolutely change the RAM you want to use on each node. With Mongo, it's always 50-50. So what ends up happening is now on each of those Couchbase nodes, in this case, 45% of the RAM is for active caching, whereas with Mongo, only that first node is for active caching. So you have 16 gigabytes for active caching as compared to 43.2 for Couchbase with the exact same hardware. So this is another reason why Couchbase performance is just way better. Someone asked in the chat, what did you test it with sharding? If you add sharding to this, it just gets worse because every shard has to have another 3 servers. It may provide some performance benefits in some cases, but it's going to be, again, a lot more hardware, more cost, and less RAM compared to Couchbase.
Okay, so let's keep digging into, so what do you got to do when you shard it and find the data, right, when you're dealing with Mongo?
Right, so we're just talking about sharding. So yeah, with an app server, for instance, you've got to run a router called Mongo S, and that's got to handle the routing of the data to where it's supposed to go. And you have to configure this with a config server as another machine that you specify, here's how I want to shard this data. And then you have to set up a shard, which is typically 3 servers for each shard. And so not only do you have to set up all this extra infrastructure, that's one thing, and Atlas can probably handle a lot of that for you. But the other thing is, when it comes to sharding, you as a developer have to figure out, how do I want to shard this? And if you get it wrong, which is likely because the shape of your data could be changing all the time, right? If you get it wrong, you're going to end up with hotspots. You're going to end up with some shards that are just like on fire. They're doing so much work, and some shards that are just sitting there cold, not doing anything. So again, it's just a inefficient use of resources unless you're so expert in sharding that you know exactly. You're like Neo in the Matrix. You know how to organize your data for each one of those shards. If you don't, you're going to end up with those hot and cold spots.
Yeah, that's a great analogy there. All right, so and then we talk about our replication capabilities, right? And we've got a couple of questions about, can we geo replicate and things like that? Yes, is the answer. And so for with our cross data center replication, you can have your different cloud environments set up in different continents. Our XDCR has filtering baked into it, so you can say send only the European data to the European cluster, and make residency requirements, and adhere to those for things like GDPR. And then of course we've got we'll talk about our edge and mobile capabilities also, but you can synchronize data to our edge servers, you can synchronize data down to clients and back, same kind of thing. Other comments here, Matt, on the XDCR?
Really, just the next slide there, I think, is going to demonstrate the main difference here between Couchbase and Mongo is that we have a fundamental difference of how we geo replicate. So each of our clusters is, or at least can be, set up as an active deployment, so it can handle both reads and writes. If you look over at Mongo, what they essentially do is just take a single cluster and spread it out amongst multiple data centers. Now, that sounds okay, except that, again, going back to the kind of primary secondary situation, in this diagram on the right, all the writes have to go through data center 1. So even if you're all over in APAC, you've got to send your writes over to North America. So that's just going to reduce increase the latency when you're updating data. And so that is, again, a fundamental difference between our architectures that leads Couchbase to have a better performance there.
Okay, so I think we've beaten up the performance angle as well as the high availability angle and the deployment flexibility kinds of things quite a bit. So now let's talk about some more of the feature capabilities that that Couchbase offers, and Mongo has some equivalents to, and but we'll get into kind of that in a sec. So we've been talking, mostly about the operational database side of Couchbase, the transactional side that's over here on this diagram on the left. But we also have analytics built into, and this is a fairly new product for us. We released it about a year and a half ago as Capella Columnar. We renamed it to Capella Analytics just because that's a cleaner name. But it's a column store that does clever things like separates your compute from storage, as good analytic systems do, supports reads and writes of very, very popular file-based data, as well as data directly from within Couchbase, or data from other systems like your like other operational systems like Mongo or DocumentDB or Postgres or whatever. And so now you can have an environment that incorporates both analytic capabilities and your operational capabilities all at the same time. Some of the great things that we just did, we just put our JDBC driver out. We have an open source JDBC driver for all of this, which is I'm just thrilled about. I'm an old analytic guy, and the key capabilities here are what's the hard part about dealing with analytics for JSON? And this is one of those areas where analytic systems, they really like structure, right? They really don't like nulls. And what we end up doing is we end up helping handle that the issues around ingesting JSON data and making it analyzable. You want to comment on that anymore, Matt?
And again, the language there is SQL again. So again, back to your BI team that may not be hardcore coders, but they know SQL. They can apply that SQL to this JSON data, or in fact, data from any of these sources, right? MySQL, Postgres, Avro, CSV, whatever.
Yeah, we're seeing some customers are doing stuff like taking data that's in Databricks and pushing it through analytics so they can write it to their operational systems in Couchbase. I find that to be really, really clever, because there's the rub that I spent 25 years in analytic kinds of systems, and the problem with every BI product or every analytic database is you can read the data, but you can't put it anywhere. You can only put it to your BI tool, and then maybe your BI tool can take some action and move it around. But the aggregation exercise doesn't do anything except post the data to somewhere else that you can read it. And then so having that write back capability, I think, is a huge, huge benefit for Couchbase, and incorporating that. It just it's common sense. And now, as we're doing things in the world of Gen AI, right, having big aggregate metrics that you can incorporate in a prompt, right, is going to be pretty handy. And then, we did work on some, exercises of trying to compare Mongo's analytic capabilities and Capella's analytic capabilities. But what we've, doing joins in Mongo is basically impossible. And I think that's one of the issues that we ran into very, very quickly. So rather than even benchmarking, what Mongo does against Capella, we just started to think about, well, why don't we just talk about what it's like to take data out of Mongo, because it's difficult, and get it into Capella Analytics.
Right. So this is still in progress, this report we're working on right now, but we've been working with a third party again on this one. And like Jeff is saying, we're using a benchmark here. It's called CH2++. This is a benchmark specifically for JSON analytics workloads. So data, JSON data-based workloads running your analytics queries on. Now, we haven't really released any data on this yet. Capella, like we've been saying the whole time here, it's better performance for sure. But one of the things we want to kind of highlight here is the ingestion that we talked about, where you can ingest data from multiple sources. And we recognize that if you've already invested time in Mongo and you already have something deployed in Mongo, we'd like you to switch to Couchbase, yes. but that can be, a time-consuming, expensive, difficult process. What you can do if you want to get analytics, though, is you can keep your Mongo operational cluster for now, and you can actually just ingest data from Mongo into Capella and use Capella as your Mongo analytics. And what you're going to see there is an increase of, again, we just have raw numbers right now, but about 100 times performance compared to the Atlas analytical tools that they have there. And then someone left a comment that I don't think they even have anything on-premise.
No.
On premises for analytics for Mongo. So that may not be an option for you even right now. But that would be an option for you using Capella Analytics.
Right. Okay, so now we're going to shift gears again. We'll talk about AI, right? Let's deal with, what are you going to do as you want to be building agentic systems? And, this is evolving so fast, right? The last 2 years has been incredible in terms of all the changes that have gone on in the market of, standing up Gen AI based applications, great chatbots, right? Great, kinds of designs around agents, except all these models still hallucinate. And that scares the crap out of everybody, as well as, giving up the data that you've curated for, years and years and decades. You don't really want to share that necessarily with a public model unless it's appropriate, right? The only areas where I see like great data sharing going on with Gen AI is actually in medicine. Where they share their scientific research always, anyways. So that seems to be a great corpus of data that Gen AI knows pretty well. But the data that you're running your business on, you want to keep that. So you need to support processes like RAG. You want to be able to support activities like vectorize the data. So use a private model to make the pointers to where a large language model might look within itself to find the same kind of data, same kind of information. So that vector activity is borne out. Now we need vector databases to live alongside our operational databases and our analytic databases. But what if, Matt, you had one system, one platform that did all this stuff at once, right? Which is, we've already mentioned, I can get rid of Elastic, I can get rid of Pinecone, I can get rid of Dynamo, I can get rid of Mongo, I can get rid of Redis. That's what Couchbase, we really do pretty well. And so being that super platform that now has these AI services built in, we have these things like, our MCP server. We released that earlier this year. We have AI functions that make SQL++ more robust. I started to talk about that a minute ago with Capella IQ and the IQ capabilities. But we've also got things when you're doing vectorization and retrieval augmented generation. Those processes are like multi-step processes that you got to deal with. You got to prepare the data for getting vectorized. We have a service for that. You've got to do the vectorization with a private model. We have services for that. You've got to do, host multiple models perhaps, right? And the interesting thing of one of our surveys came out with was most people are only using one model, right, so far. So this, the maturity level of our activity using Gen AI is still pretty early, right? Because I think you're going to want to use Claude and ChatGPT and some sort of super model that's I said super model that's purpose built for its particular function. We anticipate that kind of happening, or use a mobile model, right? And we're just not seeing that pervasiveness happen just yet. So there's still that distrust of large language models that I think is still existing. But I've got this model service that can do that and cache your results and cache your responses, run in NVIDIA's NIM microservices environment. So we've got the industry-leading environment to run these within if performance is really a big issue there. And then we've got our agent catalog, which figures out what all of those programs are supposed to be doing and helps you develop reuse strategies and helps you develop guardrailing techniques and helps you validate what the agents or the interactions are doing when they're running. Right, that's a lot of stuff here, Matt.
It is a lot. And sorry, I was looking at comments and I lost my train of thought. But one of the things you mentioned was all the different tools that you might want to stand up on their own for each one of these functions. And so, yes, that's true. We can definitely replace some of those or replace all of them. But there's also the unseen, which is the pipelines between all those tools that you also have to build and manage and maintain and fix and deploy and pay for.
Yeah. I love that. Of like, remember, RAG is a multi-step process, right, with all kinds of data touch points. And when you're doing that, you're actually having your software program, the agent has to talk to your data in the database or databases and talk to the model. So there's now like, instead of just having easy interactions between like your application and the database, you've got three things going on all at once. So your data is 3 times more complex. Your architecture might be 3 to 10 times more complex, in some cases. So it could get ugly quickly. But if you had one platform that was carrying all of that workload for you, it would be a little bit less complex, right? That's our argument. Anyway, so let's pick on mobile for a minute, because we've got in our last 5 minutes here, we've got a couple of fun ones to describe, right? Mobile, this is where the action is. Right, whether it's when you're on your cruise ship, when you're doing field service kind of things, all your Frito-Lay products are getting delivered by Couchbase Lite. Did you know that, Matt? Right, to your supermarket and everything. So your Tostitos, right? Every time you pick up a Cheeto, you're like, hey, this is Couchbase right here. Got you. That's how it got to me. So mobile's a big deal, and so we have our newest capabilities. The thing we just released earlier this year was our Edge server. That's a lightweight intermediate service that can synchronize data between Couchbase server or Capella using app services or Sync Gateway, and then its mobile clients, right? Our devices. So the cool thing about that, now you can deploy like a consolidation server on an old 737. We have a customer who's doing exactly that, right? Rewriting all of their seatback entertainment systems, but they're using Couchbase as the mechanism that's gathering and spreading the data around the plane while it's in flight. And of course, we all know that the internet's not everywhere, so you really need to have that when you're traveling at hundreds of miles an hour, and even your Starlink connection can't keep up. But then we also have this peer-to-peer syncing capability on the clients. So that even when we've got crazy customers, like there's a mining customer that sends excavation equipment underground. Terrible internet connectivity there and network connectivity there, but the machines are aware of each other through our synchronization while they're underground, because we're offline first. Other kind of thoughts here.
Yeah. I was just thinking about cruises. I'm sorry, I got distracted.
But here's the tragedy. Mongo had Realm, right? Their somewhat equivalent product, or their mobile capability, but they announced a little over a year ago they're getting rid of Realm. That was a bummer. So and September 30th is the day that they end support for all their stuff on Realm. That's a bummer. We're actually going to call that Realm Remembrance Day. And so, thankfully for us, right, we've had a number of customers have jumped, left Realm, come over to Couchbase Lite, and are, going gangbusters here. So thanks, Mongo, for that. And, just remember that this is where the action's going to be in AI, right? Because everybody carries a phone. And that's, basically our favorite and first interface to all kinds of technology, to the internet, is on our devices. So we're now the only NoSQL system that kind of lives out there for these kind of applications. And of course, ours, as I just showed here a second ago, ours has vector search built into Couchbase Lite, so you can run it on device. You can run models on the device. So, all right, let's kind of wind down here, Matt, as what do we think are the great things about Mongo versus the great things about Couchbase? Their strengths, they've got a great head start on us, right? They've got great integrations. They've got great, student hobbyist, developer appeal. Great market share, right? I got to hand it to them, right? They've got a 5-year head start on us. Other thoughts here, things that they're really good at, or that we need to give due credit to.
Yeah, I think because of Mongo's market share and size, there are other tools that claim to have API compatible solutions with Mongo. I would just say beware of those, because they're never going to be 100%. There's always going to be some 20 to 10% of functionality that's just not going to work because they're not in control of that API. So it's, it's an attempt, but it may surprise you with what it can't do. So just be on the lookout for those.
Yep. And then conversely, right, Couchbase, right, has better performance, a better scaler, AI strengths, mobility strengths, much easier to learn because it's all SQL based and things that you already know. I think those are things that make us very, very strong here. I know we're right at the top of the hour. I can't remember if this shuts itself off automatically, but hopefully not. But yeah, when we look at the world here, right, and I just take those terms that we've used in the past of like, you have great flexibility with both systems. Yes, it's JSON does all the hard work there. That's kind of the overlapping factor. But there's things like, vector is brand new, and eventing capabilities is something that doesn't exist in Mongo, and peer-to-peer, the mobile capabilities no longer exist in Mongo, but peer-to-peer sync was the thing that still made Couchbase special when they had it. And on that familiarity side, right, this the fact that our query language is SQL based and has been for the entire time. Mongo's just barely added a little bit of SQL support in their environment, mostly on their analytic services, but it's still quite limited as we've found. They have a hard time still and always jumping across shards, right, and changing data or rebalancing data or querying data across shards. They can do it a little bit, but it's still not as clean as it is with Couchbase. They have great SDKs, right, and kudos to what they're carrying there. But the other areas here, right, no caching. To speak of. I don't know why you'd say having, you're caching your data underneath the system for your key value database. I don't know that really counts because that's not where the users are. You're just saying that the thing needs to be governed. So that's what makes us significantly faster. But other elements here, Matt, you want to cover?
I just say, some of these things are limited because of sharding. And even if they did overcome those somehow, I'm going to go back to the issue of managing shards can be a real pain in the neck, and it can consume a lot of your time to get right. And with Couchbase, you just don't have that problem. Yeah.
So why would you pick us then, right? It's, here's the thing. It performs better, right? Countless times we've exercised this. Countless times we've tried it. We're comparing this. Lots of different tests. We've got it all documented. So you get better performance out of Couchbase. You get an easier to deal with query language. It's a declarative language, not an imperative language. Stronger distributed architecture, which I think we did a great job of kind of explaining to people here today. Stronger analytics solution now. As enterprise analytics has just come for on-premises. They don't have any kind of on-premises analytic capabilities here. Stronger vector support, right? And the thing that we're alluding to is coming up in short time, billion scale vectors and capabilities there, as well as vectors on mobile, which we have today, and vectors in search, which we have today, but it's getting better and stronger. Great agentic development tools, right, that go across the entire platform. And our AI capabilities are built across the entire platform to use many of the services that regular Couchbase uses and many of the services that regular Capella uses, but they're all getting built into all of those environments. A better AI model host, right? NVIDIA is hard to deny that running it where the experts are is a strong use case here. Over our agentic memory store, our agent catalog, these are things that people are ultimately going to love, and they kind of gave up on mobile. So what makes them such a strong player? They're just older than we are, right? They've been here longer, and they did a great job as an open source vendor, right? Absolutely. But for modern systems today, right, I think these are very strong arguments. Thoughts here, Matt?
No, I agree. And we say open source, that's a lowercase open source. They're not really the same open source they used to be.
True enough. Okay, final one, right? We're better value, right? Better performance, great access to JSON through all kinds of multi-purpose different vehicles. I'm glad that our audience caught that so early on. Significantly better mobile capabilities, great stuff for developers. And if you try Couchbase, you're going to love Couchbase, and demonstrably lower TCO. And the reason why I know this is because we asked our customers, and more than half of them said they cut their infrastructure costs in half after switching to either Couchbase Enterprise or Capella, right? And so in the cloud, it is true. On premises, it is true. So that demonstrably lower TCO is really what convinces folks that that's what they want. They want to be using Couchbase for these kinds of applications. So last one is here's some more resources for you to jump into. Thank you, Suzanne, for letting me continue to go overtime here. But thanks everyone for your questions. That was a really, really great discussion. Matt, you rule. Suzanne, you rule. So thank you again.
Thank you, Jeff. Thank you, Suzanne.
I didn't do much of anything, but I do appreciate you guys for being here. And yes, you will receive an email tomorrow that'll have a copy of this on demand with access to the docs, with access to this section on more resources. So we hope to see you again very, very soon.
Sign back in next month. It's important.
Yeah, hopefully we'll see you in October. Take care, everybody. Have a wonderful day.
Cheers.